its complement. We will be able to move around a few examples so that now by the end of this chapter, you are able to tackle the questions under this subtopic. So this topic is under data representation in Form 3. So in more advances, we'll be also adding more tutorials of the same. So for today, now what is this ones and twos complement formulas used to do? So you find that now in exams or in a paper, this is a paper 1 question. So you will find this one is 451. This is our paper 1. So the theory paper, not a paper 2 or paper 3 question. So in this theory, you will find that this one mostly it is meant for section A, where we have less marks awarded in a question, and it is used to tackle questions under subtraction. So when you're given a number to do a subtraction, so you find that now you will either be told to use one's complement or two's complement, and also there's a third approach of doing a direct approach. So a direct approach. So of the three, this one, the direct approach is simple. That you find that in this approach, it is doing the calculation directly. Like now an example, so that now I leave alone this one because we will not dig much into the direct approach. We find that now in this direct approach, that you are given a number, like in a binary form, let's say like a 1, 0, 1, 0, so to base 2. So the base 2 is what tells us now to which number system we are talking about. So we only have 4 types of number systems. So the numbers. So how can we write a number? So number can be written using a decimal number. The decimal numbers, these are normal numbers written to a base 10. So you see something written to a base 10. So i.e., we're writing a number like 12, and then there's a base 10. And normally also, when you see a number, these are numbers which we have been using since we are primary. So primary level. So the natural numbers. So the natural numbers 0 to 9. So any number made by a combination or a single bit 0 to 9. So i.e., like we have said here at the 12, or you can write 13. So when you write 13 without a base number, also you are referring to the decimal number. The second number we have in a number system is octal number. So what are these octal? So a bit of there. So octal numbers. So octal numbers are written to a base 8. So you write a number with a base 8. That is an octal number. So octal numbers vary from 0 to 7. So that means when you're writing a number, let's say you've written a number like i.e., you write like 32. So 32, for it to be an octal number, you have to write a base. So this one, rather than now in decimal, we said even if you don't write the base, like this one, you don't write the base for that number, you mean the decimal. This one, you have to write the base 8 here for the number that should to be a decimal number. So that means if the numbers are from 0 to 7, those are the only bits, only numbers, only characters that make up an octal number. It means that when you write like 79, this is not an octal number, simply because we have a 9 which is above 7. So only numbers made from 0 to 9. So having those 0, 1, 2, 3, 4, 5, 6, 7, 7. So 7 is the last one. So any number made by those characters, it means like 77. This one can have a base 8 because the number does not precede or is not outside this boundary of 0 to 7. So the next one is a binary number. So binary numbers are two numbers. So this is written to base 2. So any number written to a base 2, that's a binary number. So, but now we only have 2 digits. or 2 bits that are in this category, that is 0 and 1. So we don't have a number that is made up of numbers other than these 2 characters. So i.e., when you write 10, 101, you can write 101 to base 2. So this one is a binary number. But you cannot write 103. This is wrong. 103 and then you write base 2. Although there is a base 2, this one is wrong because the 3 here is above 0, is not 0 or 1. So, and the last one now is a hexadecimal number. So, hexadecimal number. So, this one is written with the base 16. And they vary from which number to which number? They vary from 0 to 9 and also from A to F. So you after these are the only characters that make up a hexadecimal. They vary from 0 to 16. So that's why we have 16. So this number, the base, refers to how many characters, how many bits are supposed to be in that number. So like here now, this 16, so meaning the hexadecimal has 16 characters. So a combination of those characters to make up a number. Like now i.e., so i.e. you can write here like A2. So let me write it here. So i.e. A2 base 16. And so on. So these ones we will dig much into our next. We will do a video for these conversions, for these how to go about these ones. But now the animal in the room, what we are doing today is ones and twos complement. So I just mentioned this one so that now we are able to know. We are able to know what we are dealing with. So because now we are dealing with these ones are the binary, the decimal. So and that is the key points for today. If you have any questions for this one, or you want me to do a future video on a specific thing or a specific topic, feel free to post on my comment section. So let's proceed. So I was talking of a direct approach. So what are these direct approaches? So a direct approach is when you do it directly. The direct approach. There is no formula to do that one. So like now when you are told that this is the number here, 1010, and then now we are supposed to subtract, let's say 101. So the minus part, this negative part here, should be less than this one. So it is ambiguous, you doing 6 minus 12 is not a nice subtraction. So always in the exams, they will have a bigger number subtracted to a smaller number. So how do we go about the direct approach? So remember when you are dealing with the decimals, or you know, when you are dealing with the binaries, zeros and ones, there are only 2. So like here, when you want to subtract 0 minus 1, it is impossible. We have to borrow. That concept for borrowing, which we have been doing from the primary level. Okay, so now the direct approach, which we were talking about here, the direct approach is doing it directly. So taking the 0 minus 1 directly. So this one minus this one is impossible. We have to borrow 1 from here. So when we borrow 1, it remains as 0. So the magnitude of this number, remember when we were doing the 6 and 2, and these are decimal numbers in primary, we were told we borrow 1 from here to remain 5. And these 2, the magnitude to go to the next one is 10. So we take 10 plus 2 to have a 12. So now in this case, we are borrowing 1. And the magnitude of these binary numbers, the binary numbers, is 2. So it means it comes here with 2 plus 0, which is a 2. So when you do the direct subtraction, that is 1, 0, and 0, that is a 0. So again, we borrow 1, it remains a 0, 2, that is 1. And this is a direct approach. So we get to this one. So this is a 0, let's retain that one. the 0 there to the down. So now, what if now you used one of the formulas of the room now? We are talking of the ones complement. Okay, so now let's do the same question using now the ones complement. So we see if we use the ones complement. So the question now is saying use ones complement to solve this question. We used here direct approach. Now I want us, this is the first method, so this is the second method. Now we are using a direct approach. So the direct approach, no, the ones complement, 1 0, this is a 1, that is 2. Okay, so in this idea, we are using ones complement to solve this question. So how do we go about now doing ones complement? So ones complement is we take the negative part, negative 1 or 1, before taking it. There's something here we have to do. So you have the first thing, let me do the question, write the question. So the first thing you're supposed to do is fill in the characters so that a character has a pattern. That is key. Remember, if they could have been arranged horizontally, so that means it is 1 0 1 0, that one minus 1 0 1. So the first thing, arrange them vertically, this one, the two terms, and then fill in the gap so that now every character has a pattern. So in this case now, we fill here a 0 so that this one has a pattern. Then now, for you to solve this using ones complement, using ones complement, you do what? You take negative 0 1 0 1, you do the not, the complement to this one. So the complement, the opposite of 0 1 0 1. So the opposite, the complement. So when you do the complement for this negative turns to a positive, a complement. The negative positive turns to a positive. This 0 turns to a 1. This one turns to a 0, this one turns to a 1, and then a 0. So, after you have found this one, in one's complement, what do you do? In one's complement, you take now this answer, and then you add the positive one, because this one was positive. So you count, this one was this one, so this one remained 10, 10. This one is a positive 10, 10, again 10, 10. So you add the 2, so that is 10, 10. It is good arranging them this way so that you can do the sum correctly. So this 0 plus 0, because here is a positive, this positive, so the negative turn to a positive. So 0, 1 plus 1, it is 2, 0, we carry 1. So 1, 0, we carry 1, and then the 1 we take it downwards. And then now, remember types of errors. We had something called overflow. So these are type of an error. So in one's complement, when we have an overflow, so in one's complement, when we have an overflow, like here now 0, with this one here, there should be always an overflow. When you are calculating this and you do not find an overflow. What is an overflow? Remember our terms have, the two terms have 4 digits, have 4 bits. 1, 2, 3, 4, 1, 2, 3, 4. So that extra one that is coming, the 1, that is an overflow. So in one's complement, we take the overflow, add it to the first one. and then you find that is your answer. You see, this one is similar to this one. So, and that is how we go about using the ones complement. So you arrange them vertically, and then fill in every bit should have a partner on the negative side. So if there are 4, don't add anything. But if this one now they were 3 and this one now they were 4, so we have to add a 0 here for each to turn to a 4. Okay. Okay, so and that is the idea. So you have to give everyone a partner. After then, you take the negative, you do the not for that one. So this negative turns to a positive. Then if it is not 0, it is 1. So the opposite. Not 1, 0, not 0, it is a 1. Because binary numbers are zeros and 1. Zeros and 1. Not of 1, if it is not 1, it should be a 0. So the opposite, the complement. So we have this one, positive 10, 10. So we take the upper one, this one, which we retain, we did not take it. So we add our not. So after you form the not, you add the 2 because this one turned to a positive. So you are combining this. When you are combining this one and this one, the combining sign is a positive. So you add the 2, and there should always be an overflow. In this question, you have to find an overflow. So to that overflow, if it is one's complement you're using, you take the 1, add it here, so that now we have 0, 1, 0, 1, and that is your final answer. Okay, let's do, for the same question, we do the 2's complement. We do the 2's complement. So 2's complement, this when if the question is saying it is telling you, is guiding you to use a 2's complement, how do you go about it? So 2's complement and 1's complement are similar. So the steps are similar. So let me rub here so that I can use here 2's complement here. So 2's complement. Now, for 2's complement, the question was 1, 0, 1, 0, 2, 1, 0, 1, and then a subtraction. So we said when we were doing 1's complement, I said we have to give every digit, every character a partner. So these ones are 3, so we add 1 for it also to have 4 characters. So similar to how we did the 1's complement is how we will be doing this one. So we take the negative 1, 0, 0, 1. So we do a not. So we do the complement to this one. So this one turns to a positive 1, 0, 1, 0. And that is what also we got at this far end when we were using 1's complement. Now this is where now things change when you are using 2's complement a little bit. So what changes? This is 1's complement here. So you add 1 to the farthest one, this bit here, you add 1. Now when you add 1, that is 10, that one. So why are we adding 1? So that now we can convert this answer to 2's complement. Remember, we did a not to this one, and this one became our 1's complement. So when now you redo, so you say, because we have done it once, so that's why we are calling it 1's complement. Again, now you want that number, this one now, like here, 10, 10, you say, I've done it once. So that is why I'm calling it 1's complement. Now, when I'm saying it is 2's complement, I should further do the not to this one so that I can have 2. So let's try, let's see. So when you do a further not to this one, it's turned to 1. If it is not 1, it is 0. This one turns to a 1, and this one turns to a 0. This 0 turns to a 1. So when you watch carefully this one, it is like you are going back to where you are. And remember, this was a positive, this turns to a negative. So you have come back to this one. So you don't do, this is wrong. You don't do it twice so that now you can say the second one is the 2's complement. No, you add one bit to the last, to the farthest one, to the last bit here, the last character, 1, so that now this one, it turns to 1's complement. So having this one and it is a positive, we have to combine this and the first term. So the first term was 10, 10. The second term here for the 2's complement is 10, 11. So these are 2, 2. So we add the 2, this is a positive sign. 0 and 1, 1 and 1. That's a 0, carry 1. 1 plus 0 plus 0, 1, 1 plus 1, a 0, carry 1, and this overflow. So what happens when we have overflows? In 2's complement, we ignore, because we added 1 earlier, and we said, when you are using these formulas, there should be an overflow. This error, mathematical error, should be there. So for you to know you are on the right track. So after you have found the overflow, you ignore it. So here in 2's complement, you ignore that overflow and write 0, 1, 0, 0 and write the rest. So when you're asked, state the difference between 2's and 1's complement, is how you are adding the 1 and how you are using the overflow. So in 2's complement, so the keywords, 2's complement. In 2's complement, ignore the overflow. But in 1's complement, add the overflow to the first digit. And that is it. So in 2's complement, ignore the overflow, but in 1's complement, add the overflow to the first digit. As we did it here, you take this one, add it here. But in 2's complement, you ignore it. And remember, for you to get a term for the 2's complement, you add 1 to the first, to the 1's complement, so that it turns to the second complement. So up to that point, hope you are good to know, and using that concept, you will be able to tackle questions under this topic. So let me do like 2 questions and then we call it session. Okay, let's finish with this one. So we're doing 1's and 2's complements. So the first one you iterate using 8 bits. So bits are characters. So using 8 characters, subtract with 7 minus 10. So 27 base 10, this is written in decimal number. So what tells us of the decimal number is the base number 10. So having a base number 10, that denotes that this type of a number system you're dealing with is a decimal number. So for you to work out using 2's complement, so we have to convert this number into the binary number system, so that now having the binary number systems which are zeros and ones, so that is now when we can be able to use the 1's and 2's complement. So let's convert this one. So we'll be using a long division to convert this. So how do we convert the decimal number to binary number? You write the number, you write the R, which is the remainder. So we are dividing and allocating our remainder. So we are dividing by 2 because we say the magnitude for the binary is 2. So we are dividing with 2 to 27. So that is 13 and a remainder of 1. So again divide by 2 until it turns to a 1 or a 0. So if 13 is 6, that is 12. The 12 is 1. 2 to 6 is 3. A remainder is a 0. So we still have a 3. We should be having a 0 or a 1. So again we divide by the 3 divided by 2. That comes to a 1. A remainder of 1. So and you write your numbers from downwards going upwards. So that is 1 1 0 1 1. There's 2. So this is the binary equivalent of the 27. So again you do for the 10 here also. The 10 base 10. So this number 2. This was the first term, the second term. So this one to binary again. So we use a long division. So we write a 10, the R for remainder, and now we start the division. So 2 to 10 is 5, a remainder of a 0. 2 to 5 is 2, a remainder of 1. So 2 to 2 is 1, a remainder of a 0. So we write two numbers, that is 10 10. So the binary equivalent is 10 10. So having the two numbers, we are told to use the 2's complement. The question says use 2's complement while using 8 bits. So now, let me use that. So 2's complement. So let's write the number. We said we have to write the number vertically, the two terms. So the two terms are 1 1 0 1 1, and the second term is 0 1 0 1. Remember, we've been told to use 8 bits. So to the first one it has 5 bits or 5 characters. So we add 3 zeros so that we make it an 8-bit system. And also this another 4, we give it 8, an extra. The 4 digits, so we were told to subtract. So the 10, this one has a negative. So remember the first step, we take the negative. After taking the negative, we do a not. So we do a complement for this one. So if it is not a negative, it is a positive. So and the 4 zeros turn to the 4 ones. So again, this one turns to 0 1 0 1. So this one is a notch to this one. And then you add the second term, which is below it. You can do it below it. So that is before that. This is now the ones complement. Remember, we were told here to use 2's complement. So we add 1 to the last term, as we said, and then the term now turns to a 2's complement. So now this one here is 2's complement. So that is how we said we're converting the 1's complement to 2's. So after that we add the first term, which is here. So 3 zeros. Okay, 11 0 1 1. So we add the 2. So this is the first one. So 1 plus 0, that's a 1. That is 0, carry 1, 0, carry 1, a 0, carry 1, a 1, carry 1, 1, carry 1, 1, you carry 1, a 0, 1, 2, 3, 4, 5, 6, 7. 7, 8. And then the carried one downwards, which is an over. And we said in 2's complement, we ignore and write the rest as your answer. So, and that is it for the question 1. So the idea was behind here, you converting the term. So you are told to use 1's complement, so there's a direction here, you use 1's complement and 8 bits. So for the second one, using 1's complement, so 12 minus 7. So we are told, so 12 minus 7. So let me erase here. So the second one guides us to use 1's complement, and we have not been told to use any bits. So it is now your choice to use maybe 1's, 2's, wherever. But for this one, we have been told to use 1's complement, but we have not been told to use how many bits. So remember what we said. After you have converted, you have written them vertically, you have to give a partner, a character a partner, and that is it. So there is no need of adding some zeros, so that now you can add it to 8 and you are not been told to do it to 8 bits. Okay, so that is 12. So we said any number, natural number, not written with a base, any number we know that is not been written with a base, it is a decimal number. So unlike this one here was written, it was indicated the base is 10. So here the 10 is not indicated. So we said when we were discussing by the number systems, we said there's no need of indicating for the decimal numbers. These are the natural numbers we have been doing from at the primary level, that is 0 to 9. So any digit, any number that has may have been written using the 0 to 9 numbers and RE, that is, let's say like 8 and 9. So that's an 8 and 9, which are combination of some digits that are from 0 to 9. So there's no need of writing this one. These are the natural numbers we'll be using. So you can write the base 10 or this. So if they leave up to the 10 here, they mean also decimal. So as we converted the first one, it is how we will convert the second one. So the long division. So the 12. Okay. So we write R for remainder. So we are dividing with 2 because we are converting this decimal number to binary. So the binary is 2, so we are dividing by 2. We will be seeing when we are converting to the other number system like octal, you will be dividing by 8 here. So you divide by 8 here and you'll be writing the remainder. So the 8. But now in this case here, you are supposed to divide by 2 because you are dealing with decimal number 2 by binary. So 6 to 12 is 6, remainder is 0. 2 to 6 is 3, remainder is 0. 2 to 3 is 1, remainder is 1. So the number is 10, 1, 11, 0, 0. So this is the binary equivalent, to 12. And the second term is 7. So we do the 7, 2, 7, the remainder. So 2 to 7 is 3, remainder of 1. 2 to 3 is 1, 1. So it is 1, 1, 1. There's 2 for there. So we are using 1's complement, so we write them vertically. So that is 11, 0, 0, and then 1, 1, 1. So we are doing a minus and subtraction. So we said after you do that one, you give a partner to every character. So this one does not have the below character, we add a 0. So, and that's it. So we are told to use one's complement in this. So you take the negative one, we normally take the negative term. You may arrange it upwards and down, so you find that you had started with a negative instead of this positive. But should we only go to a term that is negative, like now here this is our negative term, negative 0, 1, 1, 1, and then we do the not. So we do a complement to this one. So the negative turns to a positive. So the 0 turns to a 1, and the 3 ones turns to zeros. So after this one, this is now, after doing the not, this is the ones complement. So the question was saying ones complement. Okay, we don't add 1 here to turn it to 2's complement because we are supposed to use the 1. So after turning it, so you're supposed to add the 1 which was a positive one. So we add 0, 0, 1, 1, the 11, 0, 0. So you add the 2. So this is a 0, a 0, a 1, a 0, and overflow. So in one's complement, we say when we have an overflow, you take it, you don't ignore like in one's complement. You take it, you add to the first term, and now the answer to be this one, base 2. So in one's complement, we say we don't ignore. And that is it for today. So you can try this one. You can try this one using the 2's complement. You try this one using the 2's complement. You see we will be getting the same answer, and you tell us if your answer is similar to this one. See you.